First of all, this is, for me personally, an enormous privilege to attend this event. I am not a contributor to natural language processing or speech understanding or speech recognition or speech generation, but I'm a huge consumer of the consequences of the research that's gone on here at Carnegie Mellon and elsewhere, and in part from support from DARPA. Now, I thought I was asked to speak a little bit about DARPA, but I wanted to mention a few people who are part of the cohort that I knew personally while I was there. Dwayne Adams in particular, who many of you will know, returned to DARPA to be deputy director and also was the VP of research here at Carnegie for many years. I miss him, but I'm really happy to have had the privilege of knowing and working with him. Larry Druffel was another party from Carnegie Mellon who ran SEI for quite some time, but he was at DARPA with the cohort that I was with Bob Kahn and Dwayne and others. I also wanted to tell you a little bit about Dwayne's connection with speech, the part that I had a glancing blow with. He was working on speech compression. And of course, I was very interested in that because the internet was partly motivated by the idea that we could use computers in command and control. And if we were serious about that, that meant video, voice, and data. So finding a way to deal with voice was important. The ARPANET backbone had the blazing speed of 50 kilobits a second. And those of you who are familiar with this know that a typical voice channel is 64 kilobits a second, 8 bits sampled 8,000 times a second. If you're lucky, you do it differentially, you get it down to 32 kilobits. The problem with all that is you can't cram very many voice channels in a 64 or in a 50 kilobit pipe. So compression was very important. And so Dwayne was experimenting with a variety of things, partly with the assistance of Lincoln Labs and others, Danny Cohen at USC ISI and Jim Forgey at Lincoln Labs. So they came up with something called linear predictive code with 10 parameters, which basically modeled the voice tract as a stack of 9 little donuts, you know, and were changing their radius over time as the speech was generated, and that little stack was excited by a formant frequency, which you might think of as pitch. So you'd send those parameters to the other side, and then it would invert the process and produce sound. Well, it turns out that this compressed the voice stream from 64 kilobits a second to 1,800 bits a second. And you know, you lose a certain amount of quality when you do that. And the result was that anybody who spoke through this particular packet speech system sounded like a drunken Norwegian. And it was my job to demonstrate this new technology to a bunch of generals over at the Pentagon. And I was trying to figure out how I was going to do that. And I immediately remembered that one of the participants in the packet speech program was Ingvar Lund from the Norwegian Defense Research Establishment. So we did our demo by having Ingvar speak through the Autovan system, which was the defense's telephone network. And then we had him talk through the packet speech system, and it sounded exactly the same. And we didn't tell the generals that everybody would sound that way. So I also want to remind all of you that Steve made this lovely presentation this morning. He was the opening speaker, and he gave a beautiful summary of the DARPA story and the Carnegie Mellon story. So I won't try to repeat that, but I want to acknowledge how useful that was to set a historical perspective of ARPA. One of the things that I observe about ARPA and its success is that it doesn't have any laboratories, unlike the Department of Energy and NASA. And I can't tell you how important that is because they don't have mouths to feed over long periods of time. They can shift on a dime to move to different parties to do some of the spectacular and ambitious projects that they undertake. And it's that agility which informs DARPA's capabilities even to this day. And so I think that's one really important decision. The second thing that I believe is still true is that ARPA attracts people. I can't say DARPA, it's really hard for me. ARPA attracts program managers that have a bee in their bonnets. That's why we want them. We want them to come to ARPA with a bee in the bonnet to get something done. And the thing that's wonderful about the way the program managers are given freedom is that they can dive as deep as they want to into the projects that they manage. And I felt very free to dive very deeply into the details of the internet design and the protocols that went with it. So I think that's a very important property of ARPA. Another thing which is important is adequate funding, and although this 5-year time frame might be a norm, I can tell you that there are plenty of exceptions. So an example, the ARPANET project starts around 1968, and it continues to be supported all the way until 1990 when the ARPANET was finally put to rest. The interplanetary work that was just briefly mentioned got two particularly important infusions from ARPA. One was in 2000 when David Tennenthouse funded the first interplanetary architecture design. And then later in 2009, Press Marshall, who was at DARPA at the time, now at Google, supported some tests with the Defense Department to show that delay and disruption tolerant networking would actually be a useful component for tactical communications in a stressed environment. So another thing that I wanted to draw your attention to is that on my mobile is a little application called Live Transcribe. It basically takes in sound, and if it can detect any of 100 different languages, it will transcribe those languages. Now you have to tell it ahead of time which language to listen for. Today I set it for English, and sitting in the auditorium I was getting relatively good quality transcriptions of what was being said. That's a consequence of machine learning algorithms that have grown out of the work here at Carnegie Mellon and elsewhere. And for people like me who are hearing impaired, or my wife who has 2 cochlear implants, this kind of thing is like magic. And the fact that it works is really amazing. The guy that developed this particular Live Transcribe app is a deaf Russian whose name is Dmitry Konevsky, and he developed it using resources at Google because he needed it for the meetings he had to attend at Google to do his work. So I think that the thing that I want to emphasize here is that what Raj does here at Carnegie Mellon and has done for decades is what ARPA tries to do as well, which is to enable people to explore their ideas, give them the freedom and the facilities to accomplish that objective, give them the potential to try things out that don't work. At Google, we believe in that too. We don't believe in failing all the time. That's generally not a good idea. But the idea that you should try something that doesn't work, as long as you learn from it and don't keep doing the same dumb thing over and over again, that's okay. And you learn more often from things that don't work than you do from things that do work. Now, the last point I want to make on the technical side, though, is that we still must have some ways to go to make these speech understanding and speech recognition systems to work reliably. And the reason that I suggest this to you is that recently I'm a heavy user of the Google conferencing system called Google Meet, and there has an automatic captioning capability. Also, the Chrome browser now will automatically detect incoming sound, and if it detects that it's speech, it will open up a little window. And I find that very helpful, except that occasionally it makes mistakes. And recently I was in a conversation where the word vagaries showed up repeatedly, and it was rendered as vaginas. And if it hadn't been for the fact that I could actually hear enough of what was going on, I would have been extremely puzzled. Another example of this was an attempt to go to YouTube, which also is captioned, auto-captioned, and my wife and I were trying to learn more about Chinese cooking. And somewhere along the line, we stumbled into someone who was talking about using jicama, which is a Mexican root vegetable, in cooking. Now, normally we use that for salads, raw. But this woman was showing how she liked to cook the jicama, so we thought we should listen in on that. And the thing that she wanted to emphasize was that when you're cooking jicama, that it retains its crispiness when you cook it. But the rendering was that it retains crispiness. And again, if you couldn't hear what was going on, you would be really puzzled about exactly what the point was in that particular rendering. So I can tell you, folks here at Carnegie who have been historical and current inventors of speech understanding, that we could use a little more polish on the actual renderings that come out from these things. And I have no doubt in my mind at all that as long as Raj and his legacy, which is sitting here before me, continue to do this work, that we will see improvements in this space in all the days to come. So once again, I ask you to stand and applaud this man for what he has done.